Dear students, welcome to this video. I am Loay Al-Zube and I will be talking today about diffusion. This lecture is part of the Biomaterials class that I am teaching, and in this series of videos we're going to finish the topic of diffusion and talk about it and see how is it applicable and what are the important things that we need to learn about diffusion. I'm going to limit my videos between 5 and 10 minutes. This is an introduction about diffusion. This is the first video of the diffusion lecture series. In this series of videos, we're going to learn about what is diffusion, what is the definition of diffusion in general, and then we want to learn about how does diffusion occur, and we're going to identify the mechanisms of diffusion if you are working with, let's say, solids as opposed to working with liquids or gases. And also we're going to learn about why it's important to learn about diffusion and how the diffusion is part of processing. And when you talk about processing, it's processing of materials. So from an engineering point of view, materials, you need to be able to select materials, you need to be able to manufacture and process materials. And one of the things that we are focusing on is processing. So how diffusion is important in processing a material. And when we say processing, we want the material to have specific properties. So we want to alter the properties of a material during the processing period. And also, we're going to learn about the rate of diffusion and how can the rate of diffusion be predicted for some simple cases. And we will show and explain a couple of examples, very simple examples about how can we identify the rate of diffusion and why it's important, and how can we can use simple formulas to calculate key parameters of diffusion. And also we're going to discuss how diffusion depends on structure and temperature. And when we say structure, we can say, well, if a specific element or atom is going to diffuse from one location to the other location, what is the thickness of the barrier, and how long would it take to diffuse from one place to another place if we have a concentration gradient. So we're going to learn about these, and also what is the effect of temperature on diffusion. Is it going to be, if you have high temperature, is it going to be faster or slower to diffuse for a particular particle to diffuse? We're going to learn about all of these. To start, diffusion is defined as mass transport by atomic motion. And there are two mechanisms of diffusion in general. We have a mechanism for gases and liquids, and we have a mechanism for solids. In the biomaterials class, we will focus on the mechanism of diffusion for solids, because we want to process metals for medical applications. So how can diffusion be used and employed there? In gases and liquids, we have something called the random Brownian motion, and that's the mechanism of how particles move inside a gas or a liquid. We're not going to go in details into the random motion, but it's in general, it's the random motion of particles suspended in a fluid resulting from their collision with the fast-moving molecules in that particular fluid. You can look at the image here that I'm showing. So this is a typical path of a random Brownian motion a particular particle, a specific particle is taking. So each one of the angles, it's hitting something and it's changing its direction. And that's the Brownian motion. I hope that you were able to get a clear view about what is diffusion and what are the mechanisms. We are going to focus on the second part, the second mechanism, which is diffusion in solids. And we're going to learn about two things. One of them is vacancy diffusion, and the other one interstitial diffusion. And those two mechanisms happens only in solids, and they can be identified and clearly in solids. We're going to, as we move forward, we're going to be using a lot of terminologies, so new terms, and to set up the terminology that we're going to be using in the class ahead. In the next videos, we will be talking more and more about the diffusion in solids, and we will focus on vacancy diffusion and interstitial diffusion. Thank you for watching, and until next time.